talk is called morphological subconsciousness, and when I say that, okay, this is a hype. What this guy can tell. Okay, what sort of link can you establish from the molecules to consciousness? This is more like the title of a movie, like the title of a talk. Not really. I mean, I will try to draw a bridge between molecules, which will be, of course, psychedelics, and consciousness, because that is what psychedelics do. They modify consciousness. But first, I have like 3 slides which are slightly more theoretical to put into context what I think is like an approach to study consciousness independently of psychedelics. Then I will focus on psychedelics, but it's more like my theoretical thoughts on a few topics concerning consciousness. We can ask, what is a state of consciousness? Yes. You don't get it. Okay. So well, I will have to. I couldn't do like this,
For 20 minutes.
No, doesn't work. No, never mind. I can do like this from time to time at least if I get tired, or I can try to speak with louder. There, you get me? Okay, then I will have like problems tomorrow, but today I will be fine. Good. So, what is a state of consciousness is something that has been asked many times, and we don't really have a definition, and maybe it's not important to have one, but still there is a feeling of going through different states of consciousness every day. We at least go through at least 2 or 3, which is, this state of conscious awareness when we go to deep sleep, to, dreamless sleep, and some of us, not all of us, have also dreams, which seems to be a different state of consciousness. So in a sense, it is obvious to us as human beings that we go through different states of consciousness. So it is a natural question to ask, what does it mean to be in a different state of consciousness? So first, this is a crash course in what basically philosophers think about consciousness. I do like this slide because as I said, I'm not really a physicist anymore, but I gave this talk in a physics department, and this is something that physicists love because the dominant position is basically called physicalism. That is, nothing is over and above the physical, or everything supervenes on the physical, which is fancy philosophical language to state the fact that once you fix the facts about the physical world, then everything else follows. For example, consciousness. And what are the facts about the physical world? Well, whatever the physicists say. So basically the ontology of, quarks and fields and, the standard model and general relativity, all that stuff has been so successful in the 20th century that philosophers basically gave up and said, guys, you have basically whatever you say goes, and then consciousness, for example, depends fully on those things. This is the position of physicalism. And in this position, once you fix the state of the brain, you have, or a temporal process evolution in the state of the brain, you fix, so to say, the conscious content, but not the other way around. You could have different, you could have the same state of consciousness, but associated with different states of the brain. Okay? You can think about that a little bit. So I'm going. No, this is the last slide. How did this happen? No. Not that fast. So then I'm going to assume that consciousness exists because I feel it myself, and you do as well. And there are certain philosophers such as Daniel Dennett and Paul Churchland who will tell you that consciousness does not exist. But since they are not in the audience, I don't see Daniel Dennett sitting anywhere, so we will try to forget about them. Then, of course, consciousness as a consequence supervenes, depends fully upon the physical state of the brain, and this is, of course, the question that divides philosophers mostly, whether it depends upon the brain, but whether it is identical to the processes in the brain. But this is not a philosophy talk, so I'm not going to get into that question. So basically, this is how I summarized this position. You have this of course, as everybody knows, consciousness is that you have a little person in your brain. Now, I'm kidding. This is not what consciousness is, but this is how somehow it feels like, you know. If I tell you where is your consciousness, most people will point, you know, someplace here, and you have this feeling that there is a little person looking through a screen, through, you know, this very complicated movie and so on, that is consciousness. Well, and that is a function of what happens physically in the brain. So I'm going to propose an idea to try to understand states of consciousness. Well, I will make a series of hypotheses. The third one will be like the leap of faith. But the first two hypotheses you will agree with me. So this is something that philosophers usually don't do. They don't tell you where the trick is. They tell you, you know, we make this assumption, and once you realized, they have tricked you into believing that consciousness does not succeed, for example. Well, I'm an honest person, so I will tell you what the trick is. The first hypothesis is that you can describe the brain as a physical system, for example, using a tool such as fMRI or EEG, or even, you know, a sci-fi tool that can actually, you know, let you measure all the firing potential, all the firing of all the neurons at real time and so on. But whatever means that you have to measure the brain physically, then you have a notion of how close the physical state is, one state is to the other. This is not very difficult. This happens for all physical objects, right? If I measure, you know, the temperature of a glass of water and another glass of water, well, I have an idea of how close they are in terms of temperature. Well, the same you can do about the brain as a physical object. So the idea is that the states of the brain live in a space, in a space, you know, like could be three-dimensional space. It will not be a three-dimensional space because usually brains have more than 3 neurons, but in a high-dimensional space. And when I say that this metric space, I mean precisely that. There is a way to measure distance in that space. So whether one brain state is closer to another or farther away from another, right? So the second hypothesis is what I just said. The assumption that the evolution of the state of the state, you know, in this space of the brain is basically what determines what we feel in the first person perspective. So this is the assumption of physicalism, basically. So the concept is that basically you conceptualize that, that basically you of course this is 3 axes, but the brain, you know, you describe it with many more variables, so this will be like a high-dimensional space, and each point is basically the state of the brain in that moment in time, and you know, probably you know, here we are sitting in this room, so we are, you know, going through these different changes because your experience is changing because I am talking about different stuff. But then the idea is that when you go to sleep, you basically have a huge jump and you cluster the points in a different region of the space. And then if you have a psychedelic experience, you go and have clusters in a different part of the space, so that the way this point moves, you know, within the state is very small compared to when you jump from one brain state to another, and that you can actually measure, because again, we have this idea that we can measure distance between brain states. Okay, you follow me more or less? This is basically geometry applied to the idea of brain states. So here come the leaps of now. Well, this is the notion that a brain state you can actually conceptualize as brain states might not even exist, but we could define them operationally just by clustering the points in this state. In this diagram, it's obvious that we have 3 clusters, so we could say, well, maybe we have 3 states, but it's not obvious that the state is well defined. You know, people have been arguing for decades whether, you know, when you fall asleep is an all or none transition or a continuous process. Well, I think at some point the idea of a brain state makes a divide that is artificial. And there comes the third hypothesis that will be helpful for my research, but this is the leap of faith. That is, the contents of consciousness can also be described in a metric space. What do I mean by that? It means that there is a space in which a point represents how do you feel like. So what are basically the contents of your consciousness at any given point in time. And not only that, that we can compare how similar two conscious states are, or two sets of conscious contents in a certain way. So you can imagine that in the same way we say here this is the physical state of the brain, we can say this is the phenomenological state of the brain, and this distance is how similar those states are in terms of phenomenology. No, I am not saying, no, so far, what is that state, that space. Neither I am saying how in the hell we could come up with a distance, but I am assuming my hypothesis that we could eventually try to approximate, if that state exists, to come up with something that plays more or less the role of that state. So then the question, of course, is when are both spaces isometric? Isometric means that whenever a point is closed in one space, it's closed in the other. Meaning that if physically the brain is closed in two states, it means that whatever the person is experiencing in those both spaces is also similar. Okay? That is that both spaces are isometric. And this is something that will be very important because I will use this to link levels of description. So this is how we go from molecules to consciousness. So keep in mind this idea of being close in one space relates to being close in another. So of course when I have to choose what is the altered state of consciousness that I want to study, you know, to do this kind of theoretical work, or not theoretical but make it more empirical, well, we have many candidates. For example, I did my PhD working on deep sleep, anesthesia, and coma, and so on. And these things have pros, which are more or less easy to induce in the lab. Well, you don't induce a coma in the lab. That's basically a crime. Like you basically get the patient for it. But yes, anesthesia and sleep. But they have contrasts, that they are too simple in terms of phenomenology. It means that if you want to correlate two variables, right? If you want to say, I want to correlate variable A with variable B, you know, you need one of the variables will be moving, but if this is phenomenology, if this variable is always the same, that is the person is unconscious, you cannot make a correlation. You need two things to have a certain range. So if the persons are unconscious, we cannot make any meaningful correlation between the brain and the consciousness. Then there is the issue of REM sleep, and I basically came from the lab of Martin Dressler in Radboud University, and we want to do this kind of studies now with REM sleep after I gave this talk there. But as I said, the pros are that conscious experiences, of course, they are very different, or they could be very different to ordinary conscious wakefulness, and you can have this range of different experiences, but you have very little, unless you have lucid dreamers, which are people who really have controls over their dreams, you don't have much space to manipulate what's going on in the dream. Okay, whatever happens, whatever goes. Then we come to the issue of psychedelic drugs, such as LSD, mescaline, psilocybin. Now these things, if you think a little bit about it, are enormously helpful for what I want to do, because they provide safe, not all of them are going to be safe though. I will be talking about different molecules, and I will try to make a distinction between the ones that are safe and the ones that aren't safe. These are safe. They provide safe and reversible interventions that can change the state of consciousness, but also the different molecules have interact in a different way with different ways with the brain, and also the molecules elicit different conscious experiences. So you can basically, the parameter you move is the molecule that you are basically given to the person, and then you get, you ask, or you do some way to method basically to probe what is the person experiencing. So this is the reason why I decided to go into psychedelics in the first place. They have contrast those. They are not only legal, they are Schedule 1 drugs. So, well, not here in the Netherlands. I mean, psilocybin happens. I mean, you can't really buy psilocybin in the, like you buy a cigarette, but you cannot give it to someone for scientific research. That's a funny kind of schizophrenic situation. But anyway, they are not only legal, but they are a sensitive topic. What do I mean by a sensitive topic? Well, people go nuts when you talk about psychedelics. When I did my research in sleep, nobody gave a shit. When I started working on psychedelics, everything went nuts. Speaking of nuts, this person here, he is David Nutt. And this image I took, this is from the conference where basically they show up the results of the first, I took part of the study as well, of the first study of the acute effects of LSD in the human brain. So this person is David Nutt. This is Amanda Fielding. She's a very rich woman. And she's famous also because in the 60s she drilled a hole through her skull, basically under the assumption that she would expand her own consciousness. There's a video on YouTube of herself doing the drilling when she was a younger lady. And this one here is Robin Carhart-Harris, who is a friend of mine, who was basically a PI of the project, and he's a very serious scientist, and he did most of the heavy work. So these things, of course, well, basically there's something wrong here. What does it mean, LSD revealed? We already know LSD since the 50s. So now Albert Hoffman is dead, but I assume that if Albert Hoffman was alive, he would not have liked, It's not seems like David Nutt came up with LSD. Well, not really. But then, these studies, start coming on your brain on LSD, which this is not your brain on LSD. This is more like an X-ray of a person. This has nothing to do with LSD. Focus. Imaging shows the brain lit up after taking LSD. So what does it mean that it lit up? Well, I will explain to you what it means, but the media starts to get crazy. This is very, very interesting. This is Robin, my friend in Imperial, and this is how the interview started. The journalist at CNN, the first question he asked him was whether Robin ever took LSD himself, and Robin said no, and they both started laughing for like 30 seconds. That's amazing. Okay, this is David Nutt, completely exhausted in a country, I don't know which is it, talking in whatever language, trying to still publicize the show must go on. It was a very publicized work. But then things get even murkier. For example, apparently at a given point in time, a neuroscientist said that Donald Trump, of course, the biggest, I don't think Donald Trump's biggest president enemy is his ego. I think that, for example, I don't know, China is the biggest enemy to him. But regardless of that, his ego is, he has a huge ego, of course. So what if we could dismantle it for a while? Just for a while to see what happens. Then he comes back and he has all the codes to launch all the nuclear missiles. But anyway, this sounds like a very bad idea to me to give Donald Trump LSD. So who could have been so stupid of suggesting such thing? And apparently it was myself. I never said such a thing. But the only person that's mentioned is myself, because I was speaking about diluting ego boundaries and so on. And I never say that thing. I don't think Donald Trump needs to take LSD. TP finding, all reality is an illusion. Apparently this one is also one of mine as well, because there is objective reality and then there is all reality. And apparently I say something like that and people, they believe they live in the Matrix because of something I said. So, but what I find fascinating is that I started to receive emails from people. These emails were, where can I buy LSD, for example? But then also emails of people telling me experiences. And one of the emails, I found it fascinating. The email is the following. It starts question about LSD. He said, hello, Mr. Tagliazucchi. Nobody calls me that, by the way. Me and my friends have recently used LSD and noticed we could understand each other without words in our trip. We talked and thought about it and decided that our brains were fast as computers and we could predict ideas which appear in the mind of companions. Why we understood each other without words? Did we communicate non-verbal or our mind reading was an illusion? Excuse me for my bad English, with best regards, Dmitry. So I think this talk could as well be titled, what the hell happened to Dmitry's brain? Because, this is something that when people tell you, you ask, what do you study memory? What do you study autism? Well, because I think it's important. But when people ask you, why do you study psychedelics? What they want you to tell them is that, I take shitloads of psychedelics myself. Well, not really, or maybe yes, or maybe not, but my answer is usually show them this email and say, oh, this cannot be important in neuroscience. We have a bunch of Russian guys thinking that they're reading each other. So what do we know about the situation? Well, Dmitry took LSD. Luckily, because he thinks he took LSD, of course, nobody knows, but let's guess he did that. then the molecule acted on his brain neurochemistry, that is the molecular level or the receptor binding level. Then at some point, things changed at the system level, so things that we could measure with neuroimaging. And finally, he felt the way he felt, and he wrote me an email about it. So that is what is called the phenomenology, the conscious, the subjective feeling of being in that state, and he reported it to me. He wrote a narrative. So what I suggest we should do is that there are huge gaps here. I mean, from here to here, I will try to show you some evidence that we have that these things are connected. And from here to here is what people call basically the hard problem of consciousness. How can you basically link what happened in Dmitry's brain to whatever happens in his consciousness? But I will try to show you, I'm not going to solve the hard problem of consciousness, by the way, but I will try to show you some links between these levels. So there are huge gaps in what we know about these levels, so what should we do? Well, we put some dots in place, and we try to connect the dots. So the dots are, for example, the levels of descriptions I just said. And how do we do that? Well, first, we do this embedding of phenomenology in a metric space, which I yet still remind you I did not tell you what this space is. I am promising that we could find space in which we can, so to say, embed, so put points in space, meaning, these and these are different conscious states, and you have distances between these. Then we describe the physical state of the brain at different resolutions. The resolution of neurochemistry, the resolution we get with fMRI, the resolution we get with EEG, and so on. And finally, we try to look for isometries between those spaces, meaning that if being close in this space, it is close in this other space. Why this is useful? Well, because suppose that we have the whole brain, right? This is the brain. This is how I usually draw brains. And we have another conscious state here, and we have this famous space of, I have not yet told you about it, conscious experiences. This is Dmitry here, and this is ourselves here, and we have a distance. We are not reading each other's minds, so this distance is probably large. And the idea is that, of course, if different brains, so things, for example, you can measure with fMRI, you get a distance between them, and that distance is also predictive of the distance in this space. It means that the two things must be related. But if we take, for example, the sub-region of the brain, and we repeat the analysis, and we don't find that the distances are related, that might imply that that region of the brain, for example, is not important to link levels of description. This is an approach I'm going to take, and this basically goes to the idea of similarity between similarities, or first order versus second order isomorphisms. And I gave this talk in Frankfurt in the MPI a week ago, and somebody in the audience said, "You are talking about representation similarity analysis." And I said, "Well, you don't know how you call it. I do this." Then I realized that it's not exactly the same, but some other people have been thinking about this, because, as I said, nothing is new in science anymore. So the first part, the first dot I will try to tell you about, welcome, is what we know about human neuroimaging, that is what we know the least about. And first, of course, a brief introduction to serotonergic psychedelics, which you might not need if you are the Psychedelic Association, but still. You don't need to be, this is DMT, this is basically tryptamine that you find in ayahuasca, for example, that there are other ways to put it in your body, but the way that's traditional to the Amazonian rainforest is in ayahuasca. This is psilocin, which is if you go and buy, the truffles in a head shop, this basically will be causing the trip. This is LSD. These days you don't find LSD in claviceps purpurea like Hoffman did. You usually bind like this kind of bob sponge, whatever things. And this is serotonin. Serotonin is not a psychedelic drug. It's a neurotransmitter, as you all know. But you don't have to be an organic chemist to realize that these things are quite similar. You have these things called the indole ring. You have it here, you have it here, you have it here, and you also have it here. So this suggests that psychedelics act in some way by interacting with the serotonin system of the brain, and it's actually quite surprising how they do it. they act by partial agonism at the certain receptor. So you know, different cells have receptors. Receptors are useful to communicate themselves chemically. Serotonin has different types of receptors. There is one type of receptor that's called the 2A receptor. Agonism is a term, I don't know if I'm explaining things that you already know, but agonism means that it tends to activate the receptor in the same way serotonin does. It is not serotonin, but it more or less activates the receptor in the same way serotonin does. If it does it completely, it's called a full agonist. If it does not it completely, it's called a partial agonist. So this is a PET image of a compound that basically binds to these 2A receptors, and basically what you see in red is where you have the highest density of these receptors in the brain, and these receptors are located mostly from the parietal network at regions that have to do with consciousness, with perception. So it is not a surprise that if we hit those receptors, things are going to get weird in terms of consciousness. And actually this is a very striking figure. You can plot on one axis what is called the receptor affinity of the drug. So each point here is a psychedelic drug. Receptor affinity means how well the molecule fits. It's like a lock. You know, you have a lock, and the lock may fit perfectly. You know, the key may fit perfectly in the lock, or might not so well. So this is how well the molecule fits in the receptor, right? If it's perfect, it's serotonin. If it's not, well, it's not. So this is the potency of the drug. How do you measure the potency? Well, you start giving the drug to an animal, for example, a rat, and you measure something that is called a head twitch response, and when that starts happening, you realize that, okay, the effects are appearing. Still, after many years, one of the probably still the most powerful, there are most powerful psychedelics, but the most popular of all those powerful psychedelics is still LSD. LSD is active on doses as low as 50 micrograms. A microgram is a millionth of a gram. Okay, so what we did in the Imperial College study, I will show you a couple of slides about neuroimaging only, is that, for example, we found that LSD is increasing the connectivity of the visual areas of the cortex. So basically what I'm showing here is this thing here is the primary visual cortex of the brain. This is the same brain seen through different slices. This is the primary visual cortex of the brain, which we identified using something called retinotopic mapping. And basically what we're looking at is the fluctuations of the signal that we measure with fMRI, how synchronized are with those at the rest of the brain. And this is basically color-coded for the level of synchronization in the placebo condition. And this is what happens in the LSD condition. So this is what people mean that the brain lit up. And when you compare both, we see that basically in certain regions of the brain, especially in the salience network on the brain, we have a higher degree of connectivity of visual areas compared in the placebo, in the LSD compared to the placebo. There are psychometric scales that we give to the subjects. One of them they come from the Altered State of Consciousness questionnaire. That is, for example, can you rate the degree of complex visual imagery? And there is a correlation between how strong the visual imagery was and how much connectivity was increased between the primary visual areas of the cortex and the rest of the brain. Then we use techniques such as, this looks like something from, X-Men movie, but this is a MEG machine. Basically, this is something that you use to measure the magnetic fields of the brain. And this is similar to an EEG, but you pay more money for it, and you get a little bit better resolution. What we found is that there is this huge drop in the alpha rhythm, this oscillation that comes up and down around 10 times every second. And this oscillation this is something that is very robust. All the serotonergic psychedelics that have been studied using these techniques show a drop in the alpha rhythm. Psilocybin, DMT, LSD. I am missing some? There are not so many. Psilocybin, we have said already. Well, I hope. Well, basically, it happens for all of them. So, and it goes like this. This is the spectrum, and you see that you have the peak, the alpha peak for the placebo, and is really lost. So one of the theories, what could this mean, is that the alpha rhythm is known to it has many functions, and there are many aphorisms in the brain. One of the functions that's proposed is that it inhibits, processes that are not really relevant for the task that you are trying to do at the moment. So if you have less algorithm, what that could imply is that you could be seeing somehow that it lowers the threshold for the access to consciousness, but it lowers it even for your own brain activity. So what do I mean by that? Well, you know that whenever you see something, you see this pen. This pen is not like it appears to your brain in principle. You first detect all the edges of the pen, then you basically put them together, then you fill in the color, then you get the movement, but you don't see all that. You just see the final product of that. The other process are what Thomas Metzinger, for example, would call that they are transparent to consciousness. Well, the point is that I believe that psychedelic makes some of these processes opaque to consciousness, so that you can actually see them, and you can actually see the spontaneous activity of your visual cortex. And Jacques Cowan, who is a very smart mathematician working in the US, basically made this simulation of cortical columns and tried to show how it would look like if you could actually see the spontaneous activity of your brain. And it looks a lot like the post-eye visuals you get at LSD. But here I was asked, this is kind of visual stuff, I was more interested in more like consciousness, more like, things that go more into a deeper level. So I was really interested in this phenomenon. This is the phenomenon of dissolution of consciousness. Yeah. So we have two descriptions of two patients, two subjects in the study. The first one, basically, he felt removed in some way from what he will usually call himself. The second one was really having a far-out one. He basically said, this was real ego death stuff, man. He didn't say man, but you can even hear it. It was really ego death stuff, man. I only existed as a concept or as an idea. So these guys, while they are in the scanner, they feel this scale. I think this scale is really funny. This could come from a Monty Python sketch. The scale is the following. I experience the dissolving of myself or ego no more than usual, much more than usual. What does it mean, to experience? Well, under the placebo, of course, most people put 0 here. If under the placebo, somebody puts like 5 or 6, I think that this person needs to be taken to a psychiatric guard. Well, we got this course, and what I did was basically try to find those regions in the brain first in which the global connectivity changed. So I chose a region of the brain, and I say, well, that connectivity is increased with the rest of the brain under LSD compared to the placebo, yes or no? And I made this picture based on that. So the first thing we see is that we have this different network, frontal network, Folmore network, Sagis network, and none of them really fits very well those regions where I found that there was this increased connectivity under LSD. The one that really fit those regions were precisely where do we have the 2A receptors. This is not a surprise. I mean, the fact that connectivity is changed in those sites where LSD is supposed to act, because we know it acts on 2A receptors. But even then, what I did also is that I did a voxel-wise correlation analysis between the changes in this increased connectivity and the reported levels of ego dissolution. And I found a few areas. For example, these 2 areas are located in the temporal junction, and these 2 areas are located in the insula, in which there is a direct increase, correlation between the level of increased connectivity under LSD and the scores of ego dissolution, right? So we have some sort of neural basis of ego dissolution, and it's not surprising that those regions are the insula and the temporal junction. I can tell you then afterwards why.
How many micrograms you give to these people?
75 micrograms. Okay. So what we are doing now in Buenos Aires, we're saying, we have these different drugs, but these drugs are supposed to act by different mechanisms, not all of them. LSD, yes, psilocybin, yes, MDMA is a different kind of drug. So what we're doing is that we're taking the data we already have, and we're basically trying we're making machine learning classifiers that will distinguish LSD from its placebo, and psilocybin for its placebo, and MDMA for its placebo, and try to give that classifier that was trained on LSD is useful to distinguish, for example, psilocybin from its placebo. We got, this is preliminary results, we got more or less reasonable, for example, with a classifier that has been trained on LSD, we can tell you whether actually we gave psilocybin with a very high accuracy. Modafinil is a drug that is not a psychedelic, and we cannot really generalize any of these classifiers to modafinil whatsoever. So this is something that we would eventually want to link to this space of conscious experiences, which I already still promised that I will deliver, and I have not yet talked about. But we would like to say, okay, you know, if these two drugs are more similar in terms of fMRI, are they really more similar in terms of conscious experience? We did a magnetoencephalography analysis. This is a manuscript that is under eternal preparation because the student left. But basically what we have here is source analysis of MEG data. And what we have is by different spectral bands, the classifiers, for example, for this band, we have a good a classifier that has been trained on LSD can predict whether the person was given psilocybin and vice versa, but not ketamine, which, as you know, has a different mechanism of action. But this band is more like a psychedelic band. Everything generalizes with everything. So I think that this is useful to try to come up, you know, with specific bands or regions or whatever that are actually involved in the action of these things using neuroimaging. And then I will come to the second part. I think this is the most important and the one I like most. So I will have to assume that some people in the audience never took a psychedelic drug here. Some places I say, you know, well, maybe some of you didn't. Well, no, I will assume that some of you didn't. So if you didn't, you might want to know, what is it like? It's a reasonable question. I've been speaking about psychedelics for half an hour, more or less. So yeah, what is it like? Well, there is this very wonderful video about Cheryl Hare. Cheryl Hare was a very old guy when Sidney Cohen, who was a mainstream psychiatrist, made him talk about his psychedelic experience. He was really old. He was a historian. He was an author. And he was, you know, he was really frustrated. He was saying, like, you know, you can only say it is and it is and it is and try to tell people what it is. There is this more sophisticated description of how you can communicate what something it is like by Alan Watts. He said you can speak of Hinduism. This is a popular lecture on Hinduism at two levels at least: the metaphysical level and the mythological level. On the metaphysical level, you can speak in negative language. You can say, for example, what the divine, the ultimate reality, is not. On the mythological level, you may speak of what the divine is like, because a myth is an image. It's a concrete image in terms of which man makes sense of the world. So I can tell you, for example, if you ask me, that LSD is not driving a car, is not eating spaghetti, is not, and so on. But I could tell you, for example, that LSD is like having a dream, sort of. It's a dream-like experience. It's not that I'm saying that it is a dream, but I can tell you that it is like a dream. And actually, I am not the first person to say so. And this is how I became interested on this. I don't know if some of you actually saw this movie. This movie, I liked some parts of it, some parts not. I was going through a very difficult period of my life. I was with a friend and said, let's go to the movie theater. And I saw this movie and I became very, very emotional for certain reasons. But this really shaped the direction of what I did afterwards, because I realized something in this movie. In this movie, tells the story of two explorers that go to the Amazonian rainforest, Carl von Matthews and, of course, Richard Evan Schultes. That is the first person from the Western society that went. He spent like 3 years in the Colombian rainforest, and he was the first to try ayahuasca, and he took samples of ayahuasca to Harvard University, and they did the analysis and they found what ayahuasca was all about. And whenever a person in the movie, either a Tucano or a Western, speaks about a trip, they don't use the word trip, they say dreaming. For example, when Schultes in this scene is trying to convince this Tucano person to lead him to a plant that is part of ayahuasca, he says, I never dream, neither asleep or awake. What does it mean to dream awake? Well, I got the feeling that there was this analogy between dreaming and the psychedelic state. And actually, I realized that Rich and Schultes and Albert Hoffman published this book, which I own. It's a wonderful book. And in this book, you find all the time descriptions like this. The mushrooms cause both visual and auditory hallucinations with the dreamlike state becoming reality. So there is this sort of anecdotal evidence that in this space that I never told you what it is again, we will have 2 points. Dreams and psychedelic state. And then we could have a measure of a distance between them. And this distance may not be very large because of what I'm saying, but how can we do that? Well, this is where Erowid comes from. Erowid is a web page that seems, well, it looks very old, and it is. It's an HTML old website. It's from the 95 at least, in which people have been consuming drugs. Well, far before that, but they consume drugs and they upload these reports of how it felt like for them to have the experiences. And these guys, some of them, of course, are amateurs, but some of them are really nerdy guys. I mean, it's not like you go to the black market, to the dealer on the corner of your neighborhood, and you ask him to get some juicy tea. These are called research chemicals. These things you buy from companies because they are not really legal and they are not intended for human consumption, but they do anyway. And they are very precise. They really want to. This is what I call citizen science, right? Citizen science is the idea that you go and take pictures of birds, and this is this is a species of birds, and this is another species of birds. Well, this is citizen science as well. It is much riskier than going and taking pictures of birds, because this means that some guy took choosy fly, for example, and you don't want to take choosy fly. It's not a good idea. So we have all these reports. These are an example of the names of the reports for ayahuasca. You have things like, for example, I don't know, what are my favorite ones? Long-lasting trauma. My favorite fear and loathing is Amazonia. You don't know all these reports, and basically you apply something that's called latent semantic analysis. I will not go into the mathematical details, but it goes as follows. Suppose that I ask him, tell me something that happened yesterday, and you go and tell me what happened and so on, and I record what you say. And then I go to you and I tell you something different that happened to you, and you have all the recordings, and then you start to look at which words did you use. And it turns out that you use the same words in more or less the same frequency. So maybe you were not talking about different things after all. Maybe you were talking about the same thing or something that is related. So basically, latent semantic analysis is a tool to reduce, instead of using words, you use concepts. So concepts are basically clusters of words that tend to appear together in text. For example, these are titles from the New York Times, grouped by topic, politics, science, and food or recipes. And if you try to get similarity between documents before applying this method, this matrix is the similarity between the document that is, for example, politic 1 with, I don't know, science 1 here and so on. The diagonal has high values because, of course, every document is exactly the same as itself. But you don't find similarities between, for example, P1 and P2. But if you apply the method, suddenly you have similarities. This block here means that you basically grouped the politics headlines based on what they say. Okay, in science it did not work very well. This third headline was kind of lost, and in food it happened. So the idea is that we can use semantic analysis tools to get an idea of how close two headlines are. Imagine that we can also use it to get an idea of how close two Erowid reports are, or two sets of Erowid reports. So what a master's student did in my lab was exactly that. She downloaded the whole Erowid corpus, and these are really tens of thousands of reports. And she created this network. Each point in the network is a drug, right? And it's linked depending on how similar, in the semantic sense, the experiences are, right? And this is an example of this metric space I was talking about. I am not saying that this is the ultimate example of this idea that you have a space of conscious experience where you can measure distances, but this is an approximation to that, okay?
Last question. Is this just the headings, or are we using the full experience?
No, the full experiences. Actually, the full experience is grouped all by together. This point here, ayahuasca is not one experience. It's all the experience of all the almost 800 guys who wrote an ayahuasca experience all put together. So this is lots of text put here in this. So what Cami did was, you see these different colors here. This means that there are different types of drugs. For example, the purple ones are serotonergic psychedelics, but there is one cluster that is full of serotonergic psychedelics. You also have stuff like ketamine, nitrous-oxide, but mostly they are serotonergic psychedelics, but they are natural. They come usually from plants. Which ones do not come from plants? Well, some of them they don't, but many of them do, like DMT, Iboga, I don't know what the hell this is. Ayahuasca, they showed this most ayahuasca, but this is semi-synthetic. This comes from plants. This is plants, mushrooms. You don't find this in plants, and so on, okay? And then she found another cluster. Yes, sorry.
Did you try and, or your students, did they try to filter out cultural context around drug use?
There is no cultural context. These are probably all American or white people writing experiences.
No, but I mean, like, I can imagine that people use ayahuasca in different settings and they use ether.
We don't have any information because the problem with Arrowweed is that there is a huge, only one text box. What we are doing now with the colleagues of Imperial is a more sophisticated Arrowweed in which you have psychometric tests, and then you have 3 text boxes. In the first text box, you describe the set and setting. In the second, the acute effects, and in the third, the afterwards, what happened after the experience. And this will be much better than Arrowweed, but for the time being, we have Arrowweed, of course. Then there is this other cluster in which we have all these compounds. Most of them were synthesized by Sasha Shulgin, but these are except, of course, a few outliers. These are mostly synthetic psychedelics. We have this cluster in which we have these sedative compounds. We have this cluster in which we have antipsychotic compounds. This is rather weird. We have some deliriant agents. This is basically sedative compounds that come from plants, plant materials. This is my favorite one. There is a cluster that only has four drugs: alcohol, beer and wine, alcohol, hard, methamphetamine. So please be mindful of how much alcohol you drink. Then this is the pathogenic cluster. You have all these drugs that tend to increase. What do people take when they go to clubs, for example? So then I want to add one more point to this space. That one point was going to be dreams, and we actually got lots of 20,000 reports of people telling what their dreams felt like. And so a dream report. So we downloaded it all, and we applied the same kind of analysis, and basically it was the question, which drugs do resemble most in this space of conscious experiences, the experience of each drug? The hypothesis being that psychedelics, if it's true that that it is like to be in a dream, they would have the closest distance. So when we did that, we have these complicated figures, and you only need to look at this panel here and this panel here. Let's start for this one. This is for dreams of high lucidity. We could distinguish dreams of high lucidity and low lucidity. For dreams of high lucidity, the ranking, the drug that is closest in the space of the semantic similarity of the reports is LSD. It follows Lophophora williamsi, and then it follows Datura. Datura is this plant that has these tropane alkaloids that is really not a fun thing to drink or to make a tea of, because it's a deliriant. You lose awareness that you're under the influence of a drug, and you start to see all this complex imagery and so on. You don't have these insights that usually you have with psychedelics. These are the top 20 drugs, and more than half of them are psychedelics. A quarter of them are deliriant agents, and then you have dissociative agents. If you look at the bottom drugs, none of them are psychedelics, neither deliriants. You only have one dissociative agent. So this means that actually what seems to be happening is that indeed the experiences elicited by psychedelic drugs are closer to those dreams. But this is for dreams of low lucidity, right? And it changes. So the first one is no datura. It's not surprising because, again, datura is kind of a low lucidity drug, meaning that you are not aware that you are in a drug experience. So it's Rasma. Yeah, so then you can keep asking me, no, I want to tell me more what it is like to be in a psychedelic experience. I already told you it is like a dream, but it is not a dream. It is like a dream, so tell me more. Well, tell me more what it is like. So people made an analogy which I find more fascinating. The analogy is the following, and you find it already in the etymology of the word ayahuasca that comes from the Quechua language, which means the vine of the dead. The analogy is that psychedelic experience is like dying. How could this be? Because nobody is like, okay, I go and dream and then I can tell you, but nobody ever died and then came back, or maybe Jesus Christ, if you believe in that stuff, but he did not do much psychedelics anyway, we suppose. So no, it's not like people die and they come back and tell you, you know, LSD was really like dying. So how could this happen? Well, Rick Strassman has this whole idea that in the brain you have DMT, and DMT, when you are about to die and when you are born and when you have a mystical experience, you have this release of DMT, and this is causing a mystical experience. I don't buy it. I think there has to be another reason why these things are compared to death. So I got into contact with Bruce Grayson, who is a very, very serious researcher in the field of near-death experiences. Basically, when people 20% of the people, between 10 and 20% of the people go through hypoxia, you know, to cardiac arrest, and when they come back, they will tell you, I have this experience. These experiences usually, they're not always good, but most of the time they're good. I have this feeling of bliss, of moving through a tunnel, of this life review, all this phenomenology. So this is a phenomenology that we can capture because Bruce obtained around over his whole career, over 2,000 reports of near-death experiences. So we can do exactly the same thing as has been done for psychedelics, for dreams. And actually have a different theory that is not DMT, that is a different drug that will be the closest to dying in a sense of conscious content. You know why you die eventually? Well, of course, you die because if you have hypoxia, your cells are not getting enough oxygen, the vesicles that hold the neurotransmitters basically give up, and they flood the brain, so they release the neurotransmitters. One of the neurotransmitters is called glutamate, and this is a neurotransmitter that is an excitatory neurotransmitter. So basically, all the cells are firing like crazy, and when they fire like crazy, they eventually die, and this is called excitotoxicity. So if only there was a way to prevent glutamate from binding to the receptor and having this excitatory effect, we could maybe prevent not death, but at least prolong the chances of survival. And for example, ketamine does that. Ketamine, there is something that is called the NMDA receptor, which has many subunits in which molecule can bind. One of them is called the PCP site. And what ketamine does is that basically it blocks it's like, you know, putting a plug. It's like really blocking the action of glutamate at that site. So when you give ketamine to a person that is under a stroke or an ACD or whatever, that person has an increased chance of survival. You can really show that in clinical trials. So of course I did the experiment myself. I'm not ashamed of saying that I did an experiment with DMT, and I also had a high dissociative dose of ketamine, because I think that for a certain kind of research, I'm not saying that everybody who does psychedelic research should do self-experimentation, but I also think that those who want to do it should be allowed to do it, and it's not that self-experimentation gives more credence to my science, but it guides me towards perhaps the questions I would like to ask. So I was pretty much convinced that ketamine was like dying. And the results of the experience where really ketamine ranks first by far, and by any means of analysis we make, ketamine is the closest to the near-death experiences. Second comes psychedelic. Why is that? Well, we found the reason why, actually. This is very funny, and this is a limitation of the early reports. It turns out that many people, they think that they are smoking weed. And it turns out to be a high-potency extract of salvia. So when that happens to you, basically you think you're dying, because what else can be explaining all that weird shit? No? So this is, this is. And then you have all these serotonergic psychedelics. One of them is DMT, but by far the drug that is most similar is ketamine. Okay? So there are candidates for endogenous compounds in the brain. There is no ketamine in the brain, but there are candidate compounds that could do this trick of blocking the glutamate receptors. Okay, so the last part of my talk, I am more or less good in time. For how long did I talk?
An hour.
I already talked for an hour? Well, I will try to wrap it up in 10 minutes, 15 minutes. Is that okay?
Yeah, it's half past 5.
So do you want me to just cut the most interesting part? Or
No.
I will try to give in 10 minutes this. Okay, so basically, if all psychedelics act by agonism at the same receptor, the 2A receptor, how can it be that the effects are different? Right? If it's like, they hit the same receptor, there is a single mechanism, why do you have all
the
these?
same receptor?
Yes. So who could that be? Well, one explanation is something that's called functional selectivity, meaning that what happens in the cell is not only dependent on the drug that binds to the receptor, but on the shape of the drug. So different shapes give rise to different effects in the cell. Another theory, another hypothesis is that actually 2A agonist is a necessary condition to have a psychedelic effect, but agonism at other receptors can also bias what the hell happens in terms of consciousness. So we try to put this to test, and we did this basically with the aid of Sasha Shulgin. Sasha Shulgin, you probably heard about him. He passed away in 2014. This title is from the MAPS website. When people say, if somebody who is really into psychedelics says that other person who was very good at making psychedelics says, these people could have won a Nobel Prize, you don't take that seriously. But Sasha could have actually won a Nobel Prize, because what he developed were very selective agonists of 2A receptors and other receptors in the brain that were also allogenated. So they had allogens and substituents. So these are things that you can basically have isotopes that you can use PET to measure where they bind, and lots of what we know about how these serotonin receptors are distributed in the brain is because of the work of Sasha. And Sasha had in his book this wonderful sentence, which I will not read completely, but what he says that any drug, ideally, he will like to decompose in a state of like an oscillator, a number of components that when you add them together, you have the effect of the drug. Yeah. So what we did is very basically we have these three axes. We took data from airwave. We have a set of binding affinity profiles, meaning that we have different drugs, and we know how well the drugs bind not only at the 2A receptor, but at dopamine receptors, at adrenergic receptors, at many other receptors, and we have the molecular structure, which is not that important. So what the main result, well, these are the molecules that we included in the study. The first, above are phenethylamines, and the blue ones are tryptamines, and the main result is this one here. That if you plot on this axis the semantic similarity, so close the reports are in the Arrowhead database, and you plot here how similar the binding affinity profiles for 40 different receptors are, you have these positive correlations of 0.6. It's not the highest correlation in the world, but it's not something that you can dismiss by chance. So this means that knowing how a molecule binds to a different range of receptors will tell you, is informative of how similar both experiences are. we actually did the reverse engineering process. We did, well, maybe not only receptors matter, so we did this combinatorial analysis, and we basically looked for all the possible combination of receptors and tried to see which one allowed the best predictions. And of course, serotonin is there, dopamine is there, but there are other, for example, acetylcholine receptors are also there. So this means that for this isometric comparison, not all receptors are important. Some of them are, and some of them aren't. So we actually looked at what people were talking about when they were talking about drugs, about their experiences. So you have this component with this consciousness component, you know. People are talking about reality, the universe, colors, whatever. It's the body level component, you know. The thing that you feel in the body when the drug is, you know, it's a shitty thing. This one is the preparation component. It has to do with the fact that in Neurowind many people prepare their plant materials. This is the dependence component. You have things like as nausea, money, habit, dealer, and so on. And this is the therapeutic component. So we can see how much a drug is projected in each dimension. LSD has this huge peak in the consciousness component. Ibogaine has a peak on the therapeutic and the dependence component, because as you might know, ibogaine is being used to treat dependence. Cocaine has this huge peak in the dependence component. Datura has a peak in the consciousness component, but also in the preparation component, because usually you have the flowers of the plant and you have to boil them to basically have the experience. I'm almost finishing. So we even managed to match individual receptors to these dimensions. For example, we linked serotonin receptors 2A and 2B to consciousness. We link adrenergic receptors to body load, and so on. And then we replicated the whole paper, because this was, and this was amazing. People did not, the editor, so we first sent this to PLOS Computational Biology and we got 3 reviews. The first reviewer said, this is impossible. This cannot be happening. You cannot link something at the molecular level and the consciousness level. The second reviewer said, this is obvious. I mean, obviously drugs have this different action and different receptors, and they're going to change conscious experience. And the third reviewer said, this is so new and original that I don't want to do. I'm out of the process. So the editor of the second journal we sent it, still he was surprised. So he asked us to replicate the whole experiment using binding affinity data acquired by the group of Matthias Liechti in Switzerland, and we did the replication, and it worked. And still, he asked us to please include the word that the study was preliminary in the title of the paper. The paper will be out today or tomorrow, and even in the abstract. So this is nuts, but in a way the result is a little bit nuts. That you can go from what happens and when these guys are telling you in Arrowhead to the molecular level. But there is something that even is more nuts than this that I will show you now. Functional selectivity is the process by which at a single receptor, the shape of the molecule, this is LSD, interacts. It will basically recruit different molecules that pass messages along the cell so that the cell does different stuff. So instead of LSD, here you put psilocin or DMT, you're going to get different messages that are recruited. So what we did is we have this data from the group of González Maeso. These are the messengers, and these are how much they are recruited for drugs that are psychedelic. DOA, DOM, DOD, mescaline, methylpsilocin, and these are controlled. These are not psychedelic molecules. And there is a correlation. We can correlate how similar the second messengers are to the error with semantic similarity. And we do this bootstrap analysis to be extra sure, because we have error bars. And this is the distribution of correlation values we have. This is what would be called significant. And for most of the bootstrap iterations, it is significant. So what we know, and I'm finishing now, is that the reported subjective effects are related to agonism as an empoweration of receptors. But they are also related to functional selectivity at G-protein coupled receptors, like serotonin receptors. But all the other receptors that are here, most of them are also G-protein coupled receptors. So you also have functional selectivity. So what is the conclusion? What a mess. And yes, of course, the brain is complicated. Sasha Shulgin could never develop his psychic oscilloscope because the brain is highly nonlinear. Everything is more complicated than it appears to be when it comes to the brain. Otherwise, we would have universities, we wouldn't have neuroscience departments. So I have 2 slides of what we want to do in the future. We want to conduct the first neuroimaging study in Buenos Aires of mescaline. Mescaline comes from peyote mostly, not other plants. And one of the reasons we want to do it is that apparently Native American Indians have a very high disposition toward alcoholism, like double the disposition than, for example, the white people in America. And you know, this in United States, psychedelics are the cuckoo. You know, it's like it's worse than Bin Laden. Anyway, they allow these people to have their charge when they can have peyote. Why? Well, because apparently when they have these peyote ceremonies, they stop drinking. They have this saying that goes, whiskey and peyote don't mix. And this is apparently very effective for them to cut alcoholism at an early stage. So we want to study that in that sense. But also we are interested in the other peyote alkaloids, because people have only paid attention to mescaline, and there are many other alkaloids in peyote. And what I'm showing you here is ondansetron. You can buy it in a pharmacy, and you can buy it if you have vomit, for example. If you plan to take to eat mushrooms, for example, you might vomit. So this thing basically is something designed for you to, it's an antiemetic, so you won't vomit. But it so turns out that it has also been useful to stop alcoholism, so early onset alcoholism. So people that are predisposed to alcoholism, if you give them, if someone is a full-blown alcoholic, well, basically you go for ibogaine or like that, and that is a very difficult situation. But if someone is starting to develop alcoholism, ondansetron can be used. So we say, well, what if there are peyote alkaloids that resemble ondansetron in the sense that they are also antagonists of the tree receptor? And we did this thing from chemical informatics, in which we basically, these are the peyote alkaloids, and we did with this algorithmic analysis, we estimated the affinity for all these receptors of the peyote alkaloids, and we came up with candidates that could be the alkaloids in peyote. You know, this thing is not that different from this thing. Alkaloids in peyote that could be basically not mescaline, and they are not psychoactive. But what we want to do now is we want to synthesize these things without going to shale, because in the middle we have to go through mescaline, and we're going to have animal models of alcoholism and so on. So these are our limitations, but since there are no pharmacologists in the audience, I will not talk about them. Did this work in collaboration with wonderful people. Robin is a friend of mine, and meeting him in a couple of weeks. David Nutt is the guy who he's a heavyweight, not only because he's fat, but also because he really has a lot of in terms of politics, he's a very important guy. This is why in London you can do these experiments. Suresh Leo is an amazing guy working with fMRI, and Suresh is an amazing guy working with MEG. The near-death experience analysis came with a collaboration with people from Belgium and Bruce Grayson. These people are fire and earth Erowid, and I have to tell you to you people, these people are hippies. So we don't know their names. We published the papers under the pseudonyms. So the paper we got accepted, it says Enzo Tagliazucchi, Federico Samberland, and fire Erowid and earth Erowid, and nobody is really asking any question. So I could maybe submit a paper by the name of Donald Trump, and nobody would ask any question whatsoever. And this is my team. This is Fede. Fede is a very smart guy. He knows all the synthesis in Pical and Tical. He's maybe too smart, so I'm afraid he will end up in prison one day. But he's interested in basically the alcoholism project, as you can see. Cami, she did the phenomenology analysis, and she will be a PhD student in my lab next year. Carla does many things, so we cannot survive as a team without Carla. And Martina is the one who did the magnetoencephalography analysis I showed you. And thank you for listening to me for such a long time.
Thank you for giving the talk. We're going to have some questions. questions now. You can leave if you want to leave. If you have stuff to do.
Yes, please leave if you want to leave. I mean, I will not be offended.
Don't be,
Of course.
don't be afraid.
Did you ever make MRI or study on a high dosage of LSD or only?
No, there are not. No studies on those higher than 75 micrograms
I
as
can offer myself.
you can offer
Study
yourself, but then you should offer yourself not to take the LSD. You should offer yourself to convince the ethics committee. That is much harder than taking the LSD.
Okay.
Yeah.
Was there any data on dosing in the sort of semantic analysis?
No, that's the problem. The error with people, you can.
Sometimes they put sort of.
Sometimes they put, sometimes they don't.
Yeah.
I own a milligram scale on my place, but not everybody owns one. So if these people say, yeah, I took ketamine, 100 milligrams, you cannot use that information. And we cannot use, in a new survey that we are conducting in Imperial, we don't also use that information. But we do, we have something that goes like this. Low dose, middle dose, high dose. 3 categories. We are not asking about milligrams, because most people cannot really measure. So we have these 3 categories. Yes. Go on.
You mentioned these drugs work by being partial agonists of serotonin. Do we know of any drugs in a similar category that work by being antagonists in the serotonergic system?
And they are psychedelics.
Yeah.
Well, that's a wonder. Do you know who David Nichols is?
Yeah.
Well, I just sent him an email, a paper I found that in a certain type of cells that are not human cells, the 2CX compounds have been found to be antagonists. I don't think that in human cells 2CX compounds act as antagonists at the 2A receptor. I think that everything that antagonizes the 2A receptors blocks the psychedelic experience. That doesn't mean that you cannot get things that are agonists at the 2A receptors and do not elicit a psychedelic experience. For example, you have all these lysergic, ergotamine, these things that resemble LSD, but they are not really giving you a psychedelic experience. But they have not yet found a drug that is an antagonist at the 2A receptor and really gives you what is a proper serotonergic experience. Yes.
I'm very interested in understanding how psychedelics or iboga affect your addiction part.
My addiction?
Not you. In general, the problem of addiction within people.
Yes.
Iboga, I was told by someone, basically you cannot ever have a routine after that, and that's why you are actually not addicted anymore, because you just can't keep doing it.
Yes.
So he told me it's very...
I will tell you my opinion about. I am a friend of mine, Eduardo Schemberg, who works with ibogaine in ayahuasca, and I will tell you. Suppose if you're a crack addict, and I will tell you, I'm going to cure your crack alcoholism. So I have a hammer, and I will tell you the following: I give you a blow on the head, and I tell you, well, the procedure is the following: if you relapse, I give you another hammer in the head, and if you relapse, I give you yet another hammer in the head. I think that ibogaine works more or less like that. Basically, what Eduardo found is on the first dose of ibogaine, some of the people relapse. When he gives them the second dose, they don't want to do anything more. I don't want to try crack. I mean, please don't give me the ibogaine, because ibogaine it's not a fun experience overall. It's a very, you can even die. It's a very physical experience. So I guess that it has to do with many things. It has to do with this aversion toward experience, and it also has to do with psychedelic effects. People describe ibogaine like they see like a movie of their own life, and they can identify the moments in which they screwed up, and they have all these insights. But ibogaine apparently
to your brain.
What it does to
like,
the brain.
What's happening inside your brain that you get all these memories?
Well, there are no fMRI or MEG or EEG studies of ibogaine, as far as I know.
People also say they start knowing. People start feeling like a smartphone, basically. What's happening in your brain that you start to be able to acquire so much knowledge and understanding?
Well, Dmitry felt he could be like smartphone with his son,
Yeah, what is the explanation?
Well, the explanation is basically that you took a drug and your brain is messed up. So you can think that you are reading other people's thoughts, or you can think that you are talking with aliens, and basically this could be because you are really talking with aliens. That's one explanation. Or the most, I think, mainstream explanation is that your brain, basically you did something to your brain, that your brain is sort of creating this content. But one way to try to test for this is to do, for example, imaging studies, but there have not yet been any imaging studies for ibogaine because it's a complicated drug. It's not safe. I forgot to tell you that I was going to make a distinction between the drugs that are safe or not. Well, most of the drugs that I show you, other than LSD, mescaline, and psilocybin, are not. Not in the same sense, I mean that you could die of an overdose. Ibogaine is not that safe. Yes, and we have the other one, yes.
So I was wondering what the reason was that modafinil was mentioned on one of your sheets.
Well, it's a controlled drug, so to say. We have things that are psychedelics, and we have an empatogen, so we wanted to see, it will be weird if a classifier to detect, LSD can also detect, modafinil, because it's a completely different kind of drug, so it's like a control.
Oh, like a placebo.
Exactly.
Can I ask you one
Yes.
question? More general, I would like to know what is your perception or your view for like the future of the development of this field, if you're optimistic or not, and why?
Yes. What is the field then? I am not optimistic. I am. So basically, it depends on what are the questions. So you can ask me the question on many levels. Optimism in the sense of whether we will be able to buy a 2CV in the supermarket. I am not that optimistic. Optimist in terms of whether we will be able to use these tools to understand the brain. Yes. I think that actually that's what Sasha kept saying, that he was not a scientist, he was not a pharmacologist, he was a tool maker. He was making tools to study the mind. I think that I try to show you that these things can be useful. Psychedelic medicines for psychiatry, I'm not that optimistic. I come from Stockholm, for this meeting on psychedelics and psychiatry. I had this round table with David Nichols, Ben Sessa, Amanda Fielding, and a couple of other guys. And the feeling was, we're already there. We already made it. The only thing we have to do is to convince others. What is the evidence we made it? There are only two papers. We have Robbins' paper with Imperial and the Roland Griffin's paper on Johns Hopkins. What is the evidence? There are open label studies, or the concept of placebo is different. I think that we are being overly optimistic about the use of these things in psychedelics. And I suspect something else. Throughout the conference, you have these talks and posters saying that, psilocybin is useful to treat depression. Psilocybin could be useful to treat anxiety. Alcohol, basically pretty much everything. But I never saw a talk and a poster saying psilocybin is not useful to treat this. So this is a symptom of selection bias, publication bias. I'm afraid that people are reporting mostly positive studies, and they are basically putting in the desk drawer the negative studies. That is why it's absolutely fundamental that even studies that are not clinical trials, that are pilot studies, are pre-registered. Pre-registered meaning we tell the journal we plan to do the study in the way we do it, and we report the result, whether negative or positive, because there are too many positive results, and I have seen little. And this is for psychiatric, so for serotonergic psychedelics. I am absolutely 100% convinced that MDMA will be extremely useful for psychiatry and for psychotherapy in general. That I can both. I really bet lots of money that MDMA will really change things, but not. This is a different kind of substance. Yeah. Yeah. There is one over there.
Are there psychological situations or certain psychologists for which you would recommend to avoid psychedelic experience, perhaps especially with psilocybin?
Well, with all of them, I would avoid basically to take the drugs. I mean, if you have to convince yourself that you need to get courage to take the drug. Oh, this is going to fall. I'm afraid, I really need to convince myself. I need to take this. That is the wrong. You start with the wrong foot. I mean, you really need to have this deliberate choice of being sure that you want to do it. Ideally, why you want to do it. And then you have to make sure that the set and the setting are correct, meaning that you are in a place that is nice, that you are not surrounded by assholes, either you're alone or with a sitter that is someone you trust, or with other people who will take the drug but are very experienced, and then even then it could happen that things get out of control, because what happens is that we like to have controls over our thoughts. We like control. Well, I don't. I'm not a very controlling person, but some people are what they call control freaks. And when things start to get out of control in their consciousness, they want to anchor the experience. They want, no, I want out. And there is no way out unless you have you could have a lorazepam injection, but no, I mean, you have to really quiet down. You can calm down and realize that you're not fully in control anymore. So it depends on the personality as well. People who are, prone to being, to want to be in control are not good candidates. Then, of course, if you ever had a psychotic episode, you should not take psychedelics because you could trigger another one. And then there are interactions. LSD is probably one of the safest molecules in terms of interactions. You can take LSD with pretty much anything. I think the only interactions I have identified that could be risky is lithium, but not so much other things. But MDMA, for example, there are things that you shouldn't be taking MDMA with. Ayahuasca, for example, has monoamine oxidase inhibitor. That means that you could eat lots of cheese and die, for example, because you can have an hypertensive crisis. So there are also these combinations you have to pay attention to. Yes.
Do you know anything about the effects of psychedelics on neuroplasticity?
Yes, this is a very fun question. Psychedelics in the 60s, they were supposed to basically fry your neurons. LSD, for example, they will change your chromosome, your DNA will, all that stuff is not right. In fact, it turns out to be the opposite. There are certain psychedelics, such psilocybin, and I don't know if LSD, but I think DOE does it, mescaline as well, that in animals they have been shown to increase neurogenesis, meaning that in the dental shires of the hippocampus, you have increased number of neurons. So people tend to believe that this is good. I question that. Well, are we sure that having more neurons is better? Everybody, I mean, you see the point, right? We see that these drugs, psilocybin, increases the number of neurons that are here. Okay, that's happening. But do we really have any evidence that having more neurons in the hippocampus is better? We don't. But it happens.
Even there's more plasticity in general. It's not necessarily a good.
Yeah, I mean, well, if you speak of neurogenesis, they do. In terms of plasticity, meaning like changes in the fiber tracts and so on. This is a wonderful question. There are not many studies because this is probably a long-term effect. There's only one paper from a group in Brazil in which they studied the long-term effects of ayahuasca in cortical thickness. They have a plot which is like this: the age of the first use of ayahuasca and the cortical thickness at a certain area of the brain, and it goes like this. And it's fun because one of the points here says 2. So there was somebody who was given ayahuasca 2 years old. In Brazil, it's not that weird, because we have these churches, the Santo Daime, and
Who was the author of this study?
Sorry?
Who was
So
the
they
author
grew
of
the-
this study?
The author?
Yeah.
No, it's not Braulio. It's I think it's could be Braulio Araujo, but if this thing has internet, I can check you in a second.
Also, there was another recent paper
No, Braulio did not do that.
on plasticity,
I think.
but in vitro. So like that. They were showing that psychedelics
So
increase.
the brain physically grew, I understand correctly?
Yes, it changed the cortical thickness. When I search this, you can come up with new questions. Psychedelics, long-term effects. See, because the paper doesn't even
Google
say
Scholar.
ayahuasca in the title. It says psychedelics, but it's about ayahuasca. This is the paper. Long-term use of psychedelic drugs is associated with difference in brain structure and personality in humans. And the author is... I cannot scroll down because this is blurred. Shorty Rio. Draulio is there as well, but the senior author is Shorty Rio. Draulio does, I don't like this paper. Draulio does much better research than this, in my opinion.
Thank you.
No problem.
Can conclude. So, thank you again for being here.
Thanks for having me.
coming. And